chapter 6. We were on. We're talking about the starters, right?
Yeah.
Yeah, but I think you already finished it.
Did we? Um, we talked about ISGs. I think we talked about the integrated integrated starter generators. I think I did talk to you about the new systems they have, and I don't like it actually. A lot of these new vehicles have auto start, auto stop features, and I hate it because they have a starter motor that constantly turns on and turns off the vehicle every single time.
Oh,
Now,
like the ones that
Oh,
turn off when they park.
yeah, exactly.
or when they
And
stop.
what do you think they use that for?
What is it? Cautionary.
Fuel
They use
efficiency.
it to save gas, yeah.
Yeah, exactly. It's for fuel efficiency and emissions, pretty much. So if your engine's not running, well, you're not burning any fuel. You're not emitting carbon monoxide, carbon dioxide, any of that stuff. A lot of vehicles, a lot of modern vehicles have this system, and it's mostly on trucks, cars, and stuff like that. Let's see. I know the Equinox has it. The only thing is, yeah, I think they all have it now. I think it's like a mandatory thing.
Mm.
The, I don't like it. I did like the ISG, which we were talking about right now. This was a integrated starter generator, which performs many functions. Fast, quiet starting, automatic engine stop starts to conserve fuel. It recharges the vehicle's batteries, smooths driveline surges, and provides regenerative braking. Now, I know Dodge came out with a pretty cool one, and let me show you a video on it. It's really awesome because not only does it do that, but it actually adds power. It was Dodge integrated. There you go. It's called Dodge eTorque. Ah, still misspelled it. There was one video that I saw last time. There you go. It's this one. Let me switch real quick.
Bam, 100.
For the new Jeep Wrangler
Can I hear
and the
this?
new Ram 1500,
Yeah.
FCA cooked up a
Turn-
new
so
mild
check this out.
hybrid system that
There you
has
go.
some people
This
a
thing is
little
awesome.
bit
Watch
confused.
this.
So let's dive into eTorque and talk about
It's
what
kind of
it
like the
is,
ISG that I used to
what
work
it
on
isn't,
when
and
I was
why
out
you
there.
might want it,
I
and
like
of
it,
course, why you might not.
but they have a
First,
different
let's talk
feature
about
now.
what eTorque isn't. eTorque is not a full hybrid system. Generally speaking, hybrids fall into two categories. We have mild hybrids and full hybrids. Full hybrids are cars like a Prius or a Chrysler Pacifica hybrid, which drive along using just the electric motor. Mild hybrids would be vehicles that cannot drive themselves along the road using just electricity, and that's where eTorque falls. The heart of the eTorque hybrid system is the motor generator unit.
Look at that thing. It's
Instead of using a
massive.
pancake motor between the engine and transmission, FCA opted for a belt-connected unit. This is a little bit less expensive. It also makes it a little bit easier to maintain should you ever need to do so. On the 5.7-liter Hemi V8 engine, this motor generator unit sits on top of the engine in place of the standard alternator, and it's an air-cooled unit. On the 3.6-liter V6 in the Ram 1500, it's mounted on the front of the engine and it's liquid-cooled. On the 2-liter turbo in the Wrangler, it's off to the side, more like a traditional alternator, because that engine was designed with the eTorque assist system from the start. The motor generator unit operates on 48 volts instead of the traditional 12-volt systems that we find in most cars. This allows the same amount of power to be delivered with thinner and lighter cables than a traditional 12-volt system, while being safer than the hybrid systems that we see in full hybrids, which generally operate on several hundred volts. The engine management system uses this motor generator unit to do a few things. First, it generates electricity to charge the 48-volt lithium-ion battery pack and power the 12-volt system in the vehicle and charge the 12-volt battery pack. As we see in most hybrid vehicles, eTorque still uses two different batteries. We have the hybrid battery pack, and then we have a standard lead-acid battery pack that powers the 12-volt systems. At the moment in eTorque-equipped vehicles, all the accessories still operate on 12 volts. So the radio, the window switches, etc., everything like that still operates on 12 volts. Instead of drawing power all the time from the engine like a regular alternator, this system can essentially disconnect itself when the engine is under heavy load. That means it's not sapping power and you get all of that engine power to accelerate. When braking, it can actually be more aggressive at power generation, and that gives you basically a mild form of regenerative braking and helps top up the battery in those moments. This improves efficiency because if you're in slow and go traffic while you're accelerating, it will stop generating power, and then while you're decelerating in that traffic situation, it'll regenerate power back into the battery and therefore save some gas. Keeping the engine off at a stoplight is one of the key ways that hybrids save fuel. Now, the motor generator unit does not replace the traditional starter at the moment. FCA says that they have retained it in all of these engines for now because it has better cold start characteristics. So the first time you turn on your engine, the eTorque system does not start it. The traditional starter kicks in, and then the rest of the drive cycle is when the motor generator unit is starting and stopping the engine for you. Perhaps adding to the confusion a little bit, FCA also has a 3.6-liter V6 engine with a traditional start-stop system. But that's different because it just uses the regular 12-volt battery pack and basically a beefier starter motor. But that's not what's happening in the eTorque system, because the eTorque system uses that larger motor generator unit for torque fill. This is when the motor is assisting the engine, but this only happens at certain speeds, and that's important to keep in mind. eTorque does most of its work between 0 and about 1500 RPM. The motors themselves can deliver 70 pound-feet of torque on the 2-liter engine, 90 pound-feet of torque on the 3.6, and 130 pound-feet of torque on the 5.7-liter Hemi. But unlike a full hybrid, these motors don't add anything at higher engine RPMs, so it doesn't alter the peak torque, though it does change the torque curve. In the 5.7-liter Hemi, the 410 pound-foot maximum happens when the engine alone reaches 3,950 RPM, and by that time, the motor has stopped assisting. However, from 0 RPM to say 1500 RPM, the torque curve is altered, and we actually produce more torque than the 5.7-liter Hemi would be able to on its own, because we get that 130 pound-feet of torque almost at 0 RPM on up to when the engine starts taking over. In addition to helping start and stop the engine, the motor can also be used to expand the amount of time that the engine can stay in its fuel cut-off mode while decelerating, and the amount of time it can spend in its cylinder deactivation mode, because it can add a little bit of torque at those low RPMs when it's needed. We've also been told that the motor will be used to help smooth out torque delivery during transmission shifts, but the main benefit to you as a consumer would be the additional torque at those low RPMs and the start-stop ability of the engine. However, you should know that if you live in a hotter climate, you won't be saving as much gasoline as if you lived in a place like Seattle, because for now, the eTorque system does not add an electric air conditioning system. So the engine has to stay running in order to cool the cabin in those hotter climates. Depending on your climate and your driving style, you could expect to improve your fuel economy by perhaps 10 or 15%, but obviously that will vary greatly. The downside to a system like this would be some increased complexity, although hybrid battery packs have proved very reliable, and the increased serpentine belt wear, because the system does use that wide belt to connect the motor generator to the engine. And lastly, although nobody is talking about this directly, one of the big reasons that eTorque exists is because of corporate average fuel economy requirements in the United States. Engine start-stop systems have a noticeable impact on the EPA city fuel economy score because the amount of time that the engine is idling in that testing cycle. That is obviously one of the reasons that we see it on modern vehicles. Thanks for taking the time to check out this video. If you want to know what's going on under the skin of the 2019 Ram 1500 pickup truck, there's a video on our channel about that as well. In addition to that, you should see the first drive review of the 2019 Ram pickup truck coming up on our channel about a day or two after this video. I'll see you next week.
So that's one of their systems that they've been using for Dodge. Every manufacturer is going to have something different. GM has a system called Dynamic Fuel Management, which actually allows up to 7 cylinders to shut down while driving. It depends on the conditions that are actually going to happen, but they actually is able to shut down 7 cylinders and run only 1 to save fuel economy, gas, emissions, and so on. But it also has a start-stop system. Every manufacturer is going to have something different. Like I said, anytime you run into something different or new, I recommend you always look up the description and operation of what the system and how the system works before you attempt to actually check it out. Let me see on a 19. Let's see what type of system they have on the Suburban. Here is the Suburban. So remember a while back I asked you guys about these 3 little letter / number combinations.
Bless you.
What was this again? This one says KL9. This one says without KL9. This one says with KL9. What do you think that means? I think we talked about it a while back. I think it was actually before spring break. But I told you this 3 little indicator meant
They're
something.
like different models of the vehicle.
Yeah, close. They're options, regular production options, RPOs. So
Okay.
yeah, so this one doesn't have the RPO KL9, so it doesn't have that option. This one does have it, and what this actually means is it is an enhanced starter motor operation. And what this is the engine stop-start system in GM vehicles automatically turns off the engine when the vehicle comes to a stop under certain driving conditions, and can quickly restart the engine in about 0.3 seconds when commanded to do so. In order to smoothly restart the engine as quickly as possible while managing the greater number of engine starts, the stop-start system uses an enhanced starter motor that operates differently from a conventional starter motor. It has a high-performance electric motor and a stronger pinion engagement mechanism than a conventional starter. It is also independent control of the pinion and motor. So the enhanced starter motor continues using a typical pinion engagement mechanism with the starter solenoid that drives the pinion gear to engage or disengage the flywheel of the engine. When engaged, the starter motor can rotate the engine flywheel and in turn the crankshaft. So then it'll start after that. On the enhanced starter stop-start system, the operation is done in 2 separate functions inside the solenoid: the starter motor and the pinion actuator. Each function is controlled individually by the engine control module, the ECM. There are 2 separate relays to control the 2 separate parts of the enhanced solenoid. And actually, I want to see that right now. You have the KR27 starter motor relay, and you have the KR27C starter pinion actuator relay. So that's weird because I've never seen this. You actually have 2 separate relays to do 2 separate functions in this circuit. Now, I'm going to show you both these schematics, and so we can see what the difference is. And I want you to tell me how you can tell what that is. The 2 individually controlled relays allow for smooth engagement of the pinion gear into the flywheel with minimum noise and wear. When the vehicle is coming to a stop, just before the engine stops rotating at approximately 50 RPM during stop-start operation, the ECM energizes the starter pinion solenoid actuator relay to easily push the pinion gear into the flywheel gear without clash. Okay, that makes sense. Where's figure 8? It says see figure 8. I don't see figure 8. When the engine stops rotating during a stop-start operation, the auto stop mode, the starter pinion gear is fully engaged, ready for the starter motor to become energized to quickly start the engine. Okay, so what's the difference here between a regular basic starter that is on every vehicle? When let's say you're at a stop, what is different here than it is on a normal vehicle? Does anyone know?
This thing has like an auto start now?
Yeah, but if you look at here, it says when the engine stops rotating during the stop-start operation or the auto stop mode, the starter pinion gear is fully engaged, ready for the starter motor to become energized to quickly start the engine. So what's already active and ready to go?
The pinion.
Yeah. So if you look at this, on these systems, this guy right here is already contacting the flywheel, ready to get commanded to rotate the armature. So pretty much once the armature rotates, the pinion rotates on the flywheel that's already engaged, which allows it to do a very quick, fast start. That's pretty cool because I didn't know that. So that's what engages it very, very fast. So in the situation the engine has already stopped rotating, or nearly so, a conventional starter cannot restart the engine until the engine has completely stopped. However, with the enhanced starter, the starter pinion gear is fully engaged and ready to begin rotating the engine before it fully stops turning. So it pretty much engages it while it starts to slow down, that's pretty cool. Otherwise, the engine would actually have to stop rotating before the pinion can engage smoothly to begin restarting. Have you ever accidentally restarted your engine when your engine's already rotating?
Mm-hmm.
What happens?
fucking grinds.
Yeah, it grinds really bad. So the good thing about this is that it actually has a computer controlled system where it actually knows when to apply that pinion when the RPM starts to slow down. So the pinion's already on the flywheel, ready to get engaged when the computer says so. So all these have certain parameters to be met before it actually starts it again.
Wait, so does that mean that the pinion has synchros like on the gear, or it just like times it perfectly and just like sends it into the flywheel?
That's a good question because that would actually make sense. Because like a standard transmission, you have synchronizers to sync together your gear with gear, right?
Mm-hmm.
I don't know if it uses a synchronizer method or if it just times it per, with a sensor on it to know when it actually engages. That's a good
Mhm.
question. I'm not sure, and it doesn't actually tell me here. Let's see. Oh, look here. It says right here actually. So to prevent a lag in engine operation, the ECM uses a predictive speed matching of the flywheel gear speed and the pinion gear speed to engage the pinion gear into the flywheel gear without gear clash before the engine fully stops. So that's what it is.
Oh.
It is a predictive speed matching of the flywheel gear to the pinion gear. So that's what it does. That's crazy. But that was a good question because I didn't know. Like I said, I've never actually read the full description on these systems. So by predicting how long it takes the starter motor to spin up using an algorithm, the pinion gear speed can be matched to the flywheel gear speed, and the result is an almost instant restart that is possible at extremely low engine speeds. That's pretty badass. So, guys, a lot of these things are getting more complex, but it's not difficult if we actually take the time to read it, understand it, so we can understand what we're actually trying to do. So we have the operation and we understand the operation. This is with the RPO code KL9. Now, we understand it. So let's do some diagnostics on it. Let's go to our best friend, our schematics. Now, let's see. I don't think that's the right one. Hold on. Is that the one they gave us? No. I guess that's it. It's weird because I don't see KL9. Yeah, KR27. But remember it said it had two relays, KR27 and KR27C? I don't see the second one. That is weird. Hold on. Bum, 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 bum. Sometimes no. Wow, I don't think this is the right one actually. I'm not gonna lie. Because the system description operation told us that it had two relays. And on here, I only see one relay. So why is that? So if you look at here, here's my starter, but I only see one relay. It doesn't make sense. On this situation, I think this would be an incorrect schematic. Do you see anywhere on here that says KL9? I don't see anything.
Yeah, neither do I.
Yeah, it's all L96, L83, L86, but no KL9. Now, let's say I do have a vehicle that has a KL9 and you have this schematic. What's gonna happen? And you have to diagnose a circuit, circuit problem. It's not working. What do you think is gonna happen? I have a vehicle that comes in, customer states that the auto start, auto stop feature does not work. You look into your, GM information, you find out my vehicle has KL9, and then we read the description. The description says that it actually uses 2 relays, right? Like we went over it right now, KL9. This is right here. There are 2 separate relays to control the separate parts of the enhanced solenoid. KR27, starter motor relay, and KR27C, starter pinion actuator relay, all right? But the only thing that we found was this schematic. Now, in this schematic, what do you see wrong? I want you guys to look at it. Take the time to look at it, and what do you see wrong with this schematic? Anybody? We're still here? Did I lose,
Uh,
did I lose everybody?
I mean, I only see one relay.
I was gonna say there's only one relay and it's not even the correct relay.
Yeah, right? So if you look at here, you have KR27.
But not C.
Exactly. So then, what are you going to do? You can't do anything. Because if you start to try to diagnose with this circuit, you're going to get lost. Because the description operation does not have the correct information in this circuit to properly diagnose the vehicle. And this has happened before. And it kind of sucks because what you have to do, what I've done before, is I have to actually contact General Motors stating, hey, I got document 2206061 stating that it has 2 relays. I went ahead and looked it up, and your schematic does not show the proper information. So what do you want me to do? And sure enough, sometimes they actually have the proper schematic in a separate document that was not released as of right now or as of that time. So what I'm going to do is I'm going to try to go to a year ahead or a year below and see if it actually has it on that. But I would be very cautious on that because, like I said, on that, I did not see the actual correct information. So if it doesn't have the correct information, I would not attempt to do it because you're going to get lost in so many ways and it's not funny. It really does suck. Oh, that one doesn't have it either. Let's go to 18. Engine propulsion. Nope. That is very weird. Unless they never changed it. But I don't think it'd be in any other area. Engine propulsion. Let's try. No. Valve lifters, crankshaft, engine controls, data sensors. What is this? No, I don't see it in here either. Y'all can see my screen, right? Going through the
Yeah.
schematics. And yeah, this is one of those things about electrical. If you don't find the right information, What else would it be under? Maybe this? Controlled, fuel, ignition, coils, throttle, heater sensor, pressure templates. Well, let's see. Let's try KL9, see what pops up. Yeah, it takes me to the same spot. Control F, KL9. So verify the DTCs are not set. Start top system, KL9. So it does give me to the correct diagnostic procedure, but it does not give me the correct wiring diagram, which is in here. Takes me to the same spot, and it's the same schematic. So this is actually a problem here because this is not the correct schematic that we're looking for. It is missing the KR27C to control the pinion, and it does not have it. Unless I'm missing something, but to me, I don't see it. Very weird. So yeah, this would be a situation where we might have to call it in. We'd have to call GM directly and find out why my description says that it has 2 relays when my schematic does not. And if you look at here, the regular starter mode operation without KL9, which is the one that the schematic we have, it doesn't have 2, it only has 1. So more than likely this one right here without KL9 only has KR27, which is the schematic that we have right here. This is just a simple starter motor circuit that has 1 KR27 starter relay and not 2, so this would not be the correct schematic that we are looking for to properly diagnose that circuit. Does that make sense to everybody?
Yes, sir.
So we literally have the wrong one, and I can't even get the right one. And that's because I have access to GM information, and they are not providing the correct starting circuit system for a stop-start system that we have. So this would be very difficult. This would be one of those where we have to call the engineering department, telling them that document number, the schematic that we had is the incorrect one for the actual starter that we're looking for. So we can't properly diagnose it because we don't have the proper information to actually diagnose the circuit. So be very, very, very careful with that. In this instance, yes, we do not have the correct starter circuit. But if we did have just a basic starter circuit, this would it be. This is what the schematic would be. This would be the schematic for the basic circuit without KL9 RPO code. You have your BCM, which commands it's through the ignition switch. If you look at this, the only way to get this starter motor working is it is a basic relay, right? How does it really work? What does it do? What is its purpose? We have,
Amplifies small current.
yeah, exactly. Small current input, high current output.
Yep.
Now, if you look at this, always go back to relays. What is 30 receiving? Power, ground.
Power.
Power. So you have power in, you have a switch, and you have power out. Now it cannot be activated until my electromagnetic switch is commanded on. Now if you look at here, 86 and 85, that's our electromagnetic switch. What does 86 have going to it?
Also power now.
Look at it real quick.
That's brown.
That's ground. Now, where's the ground coming from? And to
On
me,
the
I
transmission module.
So yeah, so look at this. You actually have 2. On here, you have it here.
What does that white
And
square mean? That one right
that's a
there.
splice. Yeah,
What?
it's a different view for a splice. So you have one on the TCM, and you have one on G110, which just goes in there. So you have two, which is weird. So I don't understand why you would have one on the TCM. But if you look at this, you have a power circuit coming from your ECM, depending on what RPO code you have, whether you have a L83/L86 or L96, the terminals do change. If you have a L96, it is terminal 27. At connector X1, you have provided power from my ECM that is only showing you that circuit right there. When everything is okay and commanded good to go, that means that my transmission internal switch right here, this guy right here, it says good, it's in park neutral, as well as my ignition switch is good, and my BCM says it's good, which means your security system is okay. It will then apply power from this circuit, from the ECM to my relay. My relay will engage this electromagnetic coil. Pin 30 will then apply power through this 40 amp protected fuse to 87, engaging the starter motor. Starter motor is already grounded out on the actual case of the engine block, so it should be able to produce the actual current to get that starter rotated. Like I said, this schematic does not show the stop start feature, so I can't really check it because it doesn't have it. This would simply be a basic starter motor circuit, which is kind of weird because it does have the description operation for you to follow, but we don't have the actual schematics to follow this operation. So just be very careful, guys. It does happen. This is a physical example of having the wrong schematics for the wrong vehicle. If in case that does happen, it is a difficult situation because if you have, let's say, Protoman and you're working on an independent shop and you have a vehicle like this, what are you going to do? Can't do anything because you don't have the correct information. So just be very, 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 very careful with that because you will get stuck with electrical. And honestly, that's why a lot of people don't like to do electrical because half the battle is getting the information, and then the rest of the battle is diagnosing the circuits, diagnosing the wires, circuits, voltage drop, open circuits, stuff like that. But without proper information like this, it is extremely difficult to diagnose something. That's why usually when I work at home, I try to not do any electrical work from another manufacturer, being because the software that I have or whatever's on SDC is usually not complete with all the information that we need. I had a vehicle that one of my uncles had bought, and he bought a Dodge Durango off a used car lot, and it started having these weird ass problems. And well, I was able to find a few things, but I wasn't able to completely diagnose it. But from my experience, I told him, hey, you got something seriously wrong with a cylinder head, and your charging system was bypassed from the ECM directly to a 12-volt circuit, which was pretty much engaging your alternator to charge 100% all the damn time. So what do you think is going to happen to a battery if my alternator is charging 100% fully every single time?
It's gonna fry the battery.
Yeah, exactly. And I told him, you need to get this, either take it back or have them fix it correctly, because more than likely the reason they did that was to bypass the computer, whether it failed, and they don't want to spend money on a computer because they're usually like $400, $500 besides the programming. But this is gonna mess up your batteries almost every 3 months, and you can't do anything about it until it's properly fixed. So I told him I can't do anything here because one, you have a blown, not, it wasn't a head gasket, but it was a problem with the cylinder head that was acting up after getting hot after an hour. It would start to misfire really bad. I did look up some research information on Protoman and found that Dodge at that time had problems with their cylinder heads. So I told him, take it back to the place you bought it at and have them send it to the dealer and see if it's still covered under warranty. So luckily it was. So they were able to send the Durango to the dealer. They replaced the cylinder head, they fixed the alternator, and they fixed all the other things. So I was like, you can't buy a vehicle that's already has all these problems. and then I don't want to charge you for it because you just bought it. So like I was saying, you need to fight the dealer where you bought it from to fix it, or if not, get your money back. And that was my recommendation. Either they fix it or get your money back, because there's too many things wrong with it, and it's gonna be a very, very expensive fix. So sure enough, he called me a week ago, and he said, yeah, they fixed everything, man. They took it to the dealer, they fixed it all. They got the new cylinder head, they fixed the alternator. Somebody had bypassed it. I was like, I know, I saw all that. But it's a good thing they did it for free, because it was actually a manufacturer defect within that problem. So sometimes it is out of my hands. I know I could have fixed it. The only thing is, I don't like to jump into things that I don't have correct information on, because if I get stuck, it's gonna be a tough bind. So I usually decline things that I'm not too familiar with and I don't have proper information. That's why dealers are there. Dealers are there and they charge around $130, $150 an hour, because they have the latest and greatest information for the vehicles that you're going to be working on, pertaining to, new problems and situations like that. So just be careful, guys. I do want you guys to, work on your own cars, family members. If you have any like stuff that I can help you with, like schematics, I have schematics for GM. All right. So that's Pontiac, Chevy, Cadillac, anything that GM owns, I can get you schematics on. I can help you out with that. Other than that, the only other resource I can kind of recommend you is the STC website, as well as Motor Logic on Electude, because that's what I have to use sometimes when I work on vehicles that I don't know too much about, or I don't have any information. That's what I have to resource my information from, and I'll have to go with what I got. But I have declined work before, only because my information that I have is not sufficient to what I have to actually diagnose. Uh, how many have you guys done any type of electrical work at home lately, or on this, this quarantine or anything like that?
Yep.
Yep. Nope. Yep.
Headlights.
Oh, okay. Yeah. Yeah. Uh, if like I said, try to use. I mean, if you have time, if you're working on something, if you have your own car, your own project, use your material, use your digital multimeters if you have one. Because let me tell you, when I have a class for, let's say right now, spring, and then we come back for fall, everybody forgets. So what I usually do on every class is I take around maybe a day or two to recover all of the electrical stuff that we learned the first semester, so we can reuse it in every other class, because you will use electrical in every other class. And it's a very key importance for the automotive industry, because everything is becoming electrical solenoids, transmissions, suspension. You have magnet rides. You have so many different key aspects that are utilizing electrical systems. So we have to be aware that electrical is one of the base key components that we need to understand. And if you don't understand it, well, then that's when we start to ask questions. I'm telling you guys, try those simulators. So simulators are tough. They make you think, and that's what you want. Now, the only way to get better at things is to practice and read. So that's the only way you actually understand and get knowledge off of that. And that's why I try to push these electudes. Yeah, some of them are kind of boring, but a lot of the stuff is pretty important. I try to convey as much information as I can within this hour, twice a week. But guys, if you have any questions on anything during the week, you're more than welcome to message me on Discord, because I have students on my transmission class. She works on a car all the time. She always asks me, "Hey, sir, can you give me this? Can you give me that?" I'm like, yeah, man. Here, let me look it up. And I usually take the time from my busy schedule of doing nothing, and I go ahead and just give her. What did I give her last time? I gave her some schematics. I gave her some diagrams, some things that she needed. I told her what to check, and she was able to fix it. She was able to find it. So like I said, just drop a comment on there and just whatever. And if you need anything, if you're working on anything, just let me know. If you have a question or something, let me know. Pretty much. Because like I said, most of us are working from home, chilling. So if you have any questions, if you need to get better on something, let me know. If you need questions on a DVOM, let me know. If I find like a video that I like and if they can help you out, I'll show you that as well. But I mean, pretty much we're just covering some basic stuff right now on starters. I wanted to show you that ISG that Dodge has, and it's actually a pretty cool system, because it does actually add torque to the actual vehicle depending on the application as well as the certain criteria that the ECM meets. The way I see things going, like I said, I think they're more highly going towards hybrid systems as well as fully electric. But they're still trying to meet demands of the EPA and the emissions with internal combustion engines. But I feel like the internal combustion engine has already peaked at its max. Have y'all seen the Mercedes AMG 4-cylinder motor?
No. I didn't even
No?
know they had a 4-cylinder.
Yeah, so check this out. It is a beast of a motor. Check this out.
Is it an inline four?
Yep.
Or a V4? Inline four? Oh,
Can y'all see that in my screen?
yeah.
So Mercedes AMG new 416 horsepower engine is the world's most powerful 4-cylinder turbocharged engine. Turbocharged 2.0 liter inline 4 will be stuck in cars like the A45, CLA45, and the CLA GLA45. So this is going to be their newest powertrain. I feel like this is already the peak of internal combustion engine. It's a 4-cylinder turbo pumping out 416 horsepower with almost 400 foot-pounds of torque. That is very, very impressive. Of course, now you have the power of a V8, compact 4-cylinder, and the fuel economy of a 4-cylinder. So I think that's pretty amazing. But how much further can you push these internal combustion engines? Especially meeting the criteria that they need to meet. It's very tough. It's very difficult. Of course, I'm pretty sure this is a built motor. I'm pretty sure it has forged, pistons, forged crank, all that good stuff. So it's not going to be a very cheap engine. But the thing about this is they test it on these vehicles and they're able to see if it works or not. And what they do is they start to make a smaller, more generic versions and they start to incorporate it into other vehicles. So it's pretty cool. And I think it's very impressive. I mean, it says right here it's almost outputting 208.9 horsepower per liter, which is amazing.
Makes
That
more
is
than my car.
freaking amazing. It's crazy, man. I'm telling you, this is outputting more than V8s out there. That is amazing on a 4-cylinder turbo. That is crazy, crazy, crazy. So I haven't seen this. My buddy works at Mercedes-Benz. I'm gonna ask him about it. See if he can send me some pictures. I think it's freaking impressive. The last big job that he had, I don't know if I showed you guys, but he was
A
taking
spark
down.
plug one?
Yes, yeah, he was taking down the whole engine because of the spark plug strip. That is insane. So I want to see if he's actually worked on these yet. If he does, I want to see if he can send me some pictures. So I think that's crazy, man. This is like the pinnacle of internal combustion engines. And I think that's why a lot of manufacturers are kind of moving towards a fully electric system because they can actually output a lot of power with less. So, but as I'm saying, guys, electrical is key. You need to know it. You have to practice it. I know we're just covering some basic stuff, but all these basic stuff will always be applied to your more current and difficult stuff. If you understand the basics, everything else will be simplified. When we look at diagrams, when we look at information like this, don't get overwhelmed by everything that's going on. If you need to understand the circuit, always look at a description and operation. And that's when I was looking at this. Do you think you guys would have known if this was a incorrect schematic unless I would have told you?
Yeah, probably
Honestly.
once you actually started looking at it versus the vehicle, but before then, no.
Right? And that's what I want you guys to look at because sometimes you might get tricked. And just like me, like when I saw it right now, like, well, we're missing something. We're missing something because we read the description and it says it needs 2 relays, but this schematic only has 1. So that's what caught my eye, and that's where automatically it indicates that this is the incorrect schematic. But I want you guys to get that experience. I want you guys to understand, like, hey, I read the description and we're actually missing something. And yeah, you are correct. You are missing another relay because one does the pinion and one does the actual actuator. So if we don't have that, that's when you will get stuck. And I think the biggest problem that people have when starting electrical is they get overwhelmed with the situation that they're trying to fix, where they forget to, hey, just take a step back, go back to the basics, and just look at the circuits you need to look at. That's why I like the highlighter because I'm just highlighting the things we need to look at. the relay, starter motor, ground, power. That's the main things that starts the actual starter. Now, the rest of the stuff, of course, it does come into play, but take it step by step. If you have a security problem, do you think your starter's ever going to work?
No.
No, because you have a security system. Security system usually disables your starter, your fuel injectors, your uh, ECM. It can disable a lot of things. Every manufacturer is different. But that could be another problem. If your transmission is not saying that it's in park neutral, you think that's a problem?
Very much so.
Yeah, exactly. It's not going to start because it says it's in drive. That's when you start to, start thinking outside the box. Okay, my starter's not engaging. What could it be? First of all, is there any TTCs? Try to look at the live data and so on and so forth. Maybe on Wednesday, I'll try to hook up my tablet to my truck, and I'll show you some of the live data that I can show you on I have an 03 Silverado, but I can actually hook up my scanner to it, and I can live stream the information what I would show you in an actual vehicle. I have my other car, but I don't have it's not a web-based system. It's actually a tablet, and I can't really. Well, maybe with a camera, maybe we'll see. But I'll show you guys how to look at and what to look at, pertaining to specific information on what you need to look at. I'll try to get that going for Wednesday. I'll hook up the tablet. I'll take the Discord over there, and I'll show you live data from my truck, and what to look for depending on what we're looking at. Of course, we're talking about starters, so I'll show you what's going to happen when I actually turn the key on the on position, crank it over. What happens if I have it on neutral? I'm sorry, on park or reverse or neutral, to see if it actually gives you command. And all of these things you need to understand, because when you actually start to diagnose vehicles, it gets confusing, because there is a lot of components, especially on modern vehicles. On older ones, like the one that you just showed you, George, that's gonna be simple. I bet you it's just a ignition switch with a relay to a starter. That is it. Why? Because I'm thinking it has a carburetor, so all you need is fuel, ignition, right? That's all it needs. A lot of these things they're easy to run, they're easy to get going, because they didn't have a lot of electronics. It was simple. I loved it. It was easy to diagnose. Uh, so it's going to be a very simple circuit compared to something like what I'm showing you right now. Yes, it is going to be night and day difference. But if you can understand the tough stuff like this, anything else will become extremely easy. When
I'm probably gonna go buy a Switch,
Oh,
so
nice.
I could stop having to put the freaking cables together to turn on the Ford in the
Yeah,
back.
just buy I would say, is it a power ground, or how is it? How you turn on the vehicle?
I don't know. We just turn the key and then we touch them together and it starts the engine.
Huh.
It turns it.
Because if it's just commanding a relay, you can probably get a small switch. It all depends on what it is. But if it's a power
Yeah,
to
'cause-
power, you might want to get a heavy duty one.
Yeah, because all we do is we just put in the key, put it on the on position, and then we just put the cables together.
I bet you you're commanding the relay. I bet you that's what you're doing. What year is it again?
79.
Oof, I'm not gonna have a schematic for that.
Yeah.
I'll look around, but I don't think I'm gonna find one. But I bet you if I do find one, it'll be a simple schematic. I'll look around. It's a 79, right?
Yeah.
79 Chevrolet.
No, Ford.
Oh, it's a Ford. Ford what? F100?
Yeah, F-150.
F-150. I'll look around, see if I can find a starting schematic for it, and then we'll talk about it on Wednesday if I find it. But I bet you it's going to be simple. And I think those Fords actually have a positive engagement starter, which we did not talk about yet. And on those, it is no, where is it at? It actually has an external starter solenoid that people would be able to jump with a screwdriver or something like that, because the starter solenoid was outside. It was not part of a fuse block. And what happens is your starter actually has a movable shoe internally that is activated by a solenoid externally to get it going. It's weird, but Ford has used it for the longest time, and they finally transitioned to a internal solenoid and internal relay. So But we'll look at that. Let me see if I can find the schematic, and if I can, I'll bring it back on Wednesday, and we'll go over it and see what we can actually do with that.
I'm also
yeah.
gonna take off the AC thing.
The compressor or what?
Yeah, because I mean, who needs AC?
Especially in this
Make
text.
sure you get a refrigerant tank and make sure to put that shit in the tank.
Oh yeah, evacuate it. But yeah, I mean, it's usually a lot of people take out the AC also. I mean, because they either don't want it or it's expensive to fix, and usually it's very expensive to fix. I had one of my buddies call me. He wants me to fix up his AC. He was like, "Well, we gotta diagnose it first before we do anything." But let you know that AC is very expensive because components are very expensive.
I'll just get a little battery powered fan when it's really really hot.
I've driven cars without AC. It is uncomfortable after a while. So I wouldn't throw any of the parts away if you really want to take off the AC. Just keep them there.
Yeah.
But I guess we'll stop for today. Any questions for today, guys?
You wanna do my homework?
Nope. I got my own homework to do, man. I got a online certification I gotta do, and then I have to do my blueprinting and drafting. I'm gonna get started on right now. So I got homework too. Trust me, it sucks. But just continue with chapters.
So what, 5 and 6 right now? 6
Yeah.
right now?
5 and 6. If you haven't done it, we're on 6 right now, and also complete your electude for the starting systems. And that's it. Just continue with that. We'll have this week to finish it up. If you have any questions, guys, send me an @ on Discord or Remind. I'll come on here. I'll show you schematics, whatever needs to go over, and we'll go from there. Good.
Yes, sir.
Alrighty, guys. Well, then we'll see you on Wednesday, and then just let me know if you have any questions. All right.
All right, sir.
Alrighty, guys. Y'all take care.
Oh, sir, freaking one of my professors from my other class reminded me how much of a life I don't have.
What did
He's
you
like,
say?
all right. He's like, all right. I gotta check my leg to see who's been doing the work. It was Munoz,
Oh my God.
and he's like, oh, Jorge, 9 hours. I'm like, oh, don't tell me that, dude. I didn't want to know how long I spent on the leg, dude.
I was gonna say, I think I'm at like 13 hours now. 13,
Oh damn.
14.
That's pretty good.
I'm like, don't tell me it's 9 hours, man. Like,
But I kind of like electude because it kind of throws like the theory and a little bit of like hands-on together. I think it's a pretty cool way to learn. I like it. I was doing a couple of them.
It's honestly
mean,
annoying how it docks points when you do something that you just do out of instinct.
Yes, that's the only bad thing. Don't worry about it too much on the grading on that. I think it grades
Yeah.
a little too tough.
yeah. I mean, I've been doing okay, 60s, in the last, right now in the starting system.
That's
but
not bad.
What's it called? Like sometimes I do like really shitty on the thing, and then on the quiz, like I do
In the
pretty
butt.
good.
Those quizzes
Yeah.
are crazy
So-
easy.
Yeah,
Yeah.
should be. That's good.
But also, like I don't have a mouse,
Uh-oh.
and my pad is really messed up and it's old. So it's
For
like,
the
oh,
laptop?
click on this specific spot. I'm like,
Oh
okay,
yeah.
and it's like, oh, it's wrong. It's like, come on.
Yeah.
And then I try using my finger, and my finger is too fat, so it's like, oh, it's wrong. I'm like, come on.
Oh man.
So I get frustrated, and I just don't do anything for the rest of
Damn.
the week.
Just do as much as you can, guys. Like I said, we have this week for chapter 6. If you haven't done chapter 5, make sure chapter 5 is done. I am slowly inputting grades when you guys complete it. I am inputting the grades. We'll have this week, and then we have the next 2 weeks for chapter 7, and the last week is pretty much going to be final, which we will need lockdown browser. I'm gonna go ahead and set that up when I get a chance, and then I'll let you guys know when to do that.
Bologna sandwich. Try
But
Sandwich.
Sandwich.
right?
Try it for you.
Too funny.
Try it.
But yeah, that's it, guys, for today. If you have any questions, guys, just let me know, and we'll help you out with that.
Shit about to kick your ass, Brian. Damn.
Oh, I know. Let me go off there real quick. Did it turn off the live stream? Yeah, it
Yes,
did.
it did.
Cool.
No,
Alrighty, guys.
what's called?
I'll see y'all later. Oh, what's up? Okay. Wait.
Y'all have a good one.
Peace.